Hello.
Hey,
So we're gonna dual queue this. Maybe Joey's gonna come.
I forgot to sign up though. I need to. It starts in 30 seconds, so fuck. Oh fuck.
Should
Okay.
be fine. Should be fine.
Hey, do we both register?
I'm registered already.
Okay. Well, I just registered. Should
Yeah.
I register? I don't know.
Oh yeah, you're fine. We can both register.
Whatever. Okay,
Okay,
starting.
that.
And by n grid, strictly increasing. Uh, all columns. Okay.
Column strictly increasing.
Uh, fuck, I need to change my key bindings to Vim
So it's
for J.
columns of 3,
M
1,
equals
3. Okay.
round and J for I in range. Um, or equals
Uh,
grid 1 0 J.
it's the length of the
Um,
row. So
and 0 very good. J.
4. Okay. Hmm.
This is like surprisingly annoying for a question one.
Yeah, it's pretty annoying. Okay, so yeah, I think we go column by column, and then you just
Yeah, it's just
yeah,
it's
plus one
easy. It's
subtracted
just
by whatever.
it's easy. It's just annoying.
Yeah. Row, column. So J is the row. I think this is column, right? It's row. So this is this one. So the operation would be the previous one. This one. You do plus one. That's what you target. And there's a case where you don't need to do it. Oh,
15, 12. Okay, I solved it.
you finished it already? Damn.
Yeah. Find the largest.
Uh,
What? Who's that? Is that Joey?
is Joey here? I don't think so. No, he's not here.
No, someone joined and then immediately left.
Oh, I didn't even hear the Discord sound. Uh, oh no, we didn't need to make an operation on that. Oh yeah, so it should be fine. Okay. Good morning, someone says in my chat. Oh, whoops, grid row. Uh, So 15 is the answer for this one. 15, 12. Okay, good. Finally finished. Caught up to you. Okay, find the lexicographically largest string from the box ones. So it's Q. Okay. Given a string
What do you
word.
mean multiple rounds? Description is so ass.
I'll look at the examples. Fuck it. Okay, never mind. I don't get it. Is this a reading comprehension question?
I think so. It doesn't look very hard, but
Alice is organizing a game for her non-friend friends. There are multiple rounds in the game where in each round the word is split into non-friend, non-empty strings, such that no previous round has had the exact same split. What the fuck? All the split words are put into a box. Find the lexicographically largest string from the box after all the rounds are finished. String A is lexic. Okay, that's just the definition of lexicographically, blah, blah, blah.
said no previous round has had the exact same split.
Wait, words.
What do you mean?
Word is
What
split
the fuck do you mean
into.
exact?
I don't get it. Word is
I
split
don't
into
get it. I'm looking.
non-friends, non-empty strings. Okay, so it's split into, for example, one split into two strings. Okay,
Just
so
call it K. It's split into K substrings.
yeah. Okay, so they split it into k substrings. So these are all possible splits,
Yeah.
such that no previous round has the exact same split. So I guess it means you're doing all possible splits. All the split words are put into a box. To find the lexicographically largest string from the.
Okay, but you only split once. This fucking multiple round shit is bullshit. You only split once. That's what the
Yeah,
question is saying.
yeah. So you just. So what's the lexicographically longest string from splitting?
Yeah. I mean, you just do greedy, you know?
It's greedy. Uh, I think so.
This is
So
a
you.
fucking reading comprehension question. I think it's literally one line, is it not?
Oh wait. So how would you do that? You want.
No way, it's not. It's not one line. I lied. Um,
Is there a linear way of doing it? You go through. Um. Yeah. So here. It's just like if we like brute force it, just for like hypothetical, it just means you get all the possible ways to split it into k ways, and you take the biggest one lexicographically. That's
brute
the
force is too slow.
no, but that's like the essence of the question.
Yes, but I think you can just greedy find the largest substring.
Yeah, the
Um,
largest substring. As long as there's room for like splitting the rest,
yeah,
though.
it has to. There's a maximum length cap on it, but
Yeah, there's a length cap on it, but there's no minimum. The minimum is just one, right?
yeah, because you can always take a single character
Yeah. So
given the
so let's say for DBCA. So since you have two friends, you can take DBC. So the remainder, so you take like yeah, so you look at each like substring linearly and then you cut off like k minus one or oh does yeah k minus one starting from like the ith index, right?
I think what I can do is just I can just search for the wait.
Uh,
It only goes up to 5,000. So I think what you can do is you can just I can just look for the largest character in the string, and then from each location where the largest character occurs, I can just take a substring of
so
max
so
length.
it'd be like two pass.
Yeah. Well, like I collect all the largest ones and then just slice and then take the max.
That is true. That is true.
Yeah, and where
Uh,
uh,
and how do you know what length to take the slice?
it's based on numFriends.
Yeah.
Largest equals max.
Hmm.
Can I just do max on a string? That should work, right?
I think so.
See. Uh, this is
Yeah, it works. Uh, mm,
it's fucking reading comprehension question is crazy.
yeah.
Yes.
Uh,
And word. Yes. Wrong answer. What the fuck? Yes. Okay, I solved it.
I solved it. Damn. Too
Yeah.
fast.
I got one wrong answer though, because I didn't consider the and numFriends equals one edge case.
Oh.
Okay, question 3. Special subsequence, PQRS. Okay, the products are the same. Q minus P greater than 1.
0, 1,
This
2.
is some stupid ass DP question or something. Or no, like, I don't even know how to describe this.
Uh, mm, uh,
Not a lot of points on this one.
mhm.
Dude, more people have done question 4 than question 3.
That's crazy. Wait, what did I troll here? No need
Question 4 might actually be
parentheses.
easier. It looks easier though. Why is question 4 always DP?
Wait, why can't I do mathematical operations in the index?
Type int and list.
Oh, whoops. Wait. Oh no,
Okay.
it's here. It's I. Oh no, this is right though. Oh, whoops. No, I'm trolling. DBC G. Okay, let's try this. Fuck, oh, is that in one friend's edge case? What did mine return? Oh, an empty string. What? 0, 1. If there's index 1.
Actually, this is like a combinatorics question. I don't know how to do it. Be at least one element between each pair of indices.
Wait, what? A, B, C, D, E, F, G, H. Wait, does G come before or after H? A, B, C, D, E, F, G, H. Wait, what? What is the one G, H? Oh my god, am I retarded? Alphabet.
Hmm? What do you mean?
Because for this one, it says that it expects GH as the answer. But isn't
Well,
H?
you can't split the string because it's only one
Oh,
friend.
oh, I'm dumb. Yeah, you're right. I can't split it. Okay, so if there's just one friend, it's just the whole string.
Yeah.
Okay. Yeah, I'm not very smart sometimes. Oh, I'm cooked. Two wrong answers. One, zero, one. Okay. So is my end index wrong? Uh, 1, 1. Oh god. Okay, that's bad. Length of words. So that's 3 minus I. So that's 1. Wait, why did I do that? Is it just minus num friends here? No, still not good. Okay, no, that's num friends. But everything before can already be split. Okay. Okay, there we go. So G, is that correct? Yeah. This is DBC. Okay, I think I was just bad at math. I hope that's it. Okay, there we go. Next. Oh,
Nice.
man.
This is an interesting question.
Count special subsequences. Wait, you saying 4 is easier?
Or is like a discrete math.
Okay.
combinatorics type of question.
I think also because sometimes like the top people in contests they do question four first and then they go backwards.
Yeah, that's true. It's worth the most after all.
Wait, again, a special subsequence is defined as a subsequence of length 4 represented by indices PQRS where they're increasing order. Satisfy this condition. P times R equals Q times S. There must be at least one element between each pair of indices. In other words, okay, so they can't be consecutive. That's what they're saying.
Yep.
A subsequence is a sequence. So that just means we're picking four elements. Uh, and they have to be in order, such as the two left. Multiplying the two left is equal to multiplying the two to the right. The fuck? The number of different
No,
subsequences.
it's actually interleaved. It has to be P times R, Q times S.
Oh, okay, it's interleaved. You're right. Okay. 0, 2, so 1 times 3. Wait, is that it? 0, 0, 1,
I think I have
2,
an idea.
3. Oh no, it's 0 times the 4. 0, 1, 2, 3,
Needs to be
4,
hash map.
3, 0, 1, 2, 3, and 6.
Like this seems easy to count manually.
Someone wrote I could be finishing the Sonic 2 movie instead of doing this contest.
Yeah, I still need to watch the Sonic movie,
Are
the
you,
new one.
you're gonna go watch it?
I want to.
Because, is it because of, is it Shadow or what's his name?
Yeah,
The,
Shadow's cool.
yeah, I watched a trailer. The fight scenes look pretty cool. Ay, is it a brute force?
It might be.
Are you brute forcing this?
I'm trying.
Okay. Uh, yeah, I think it's a counting problem. I don't think there's any clever way of
I
doing
don't.
it.
Yeah, I can't think. It's n equals 1,000. Like, it's not that big.
Yeah. uh, okay. I'll try to brute force it too. Right. Exclude 3. BR. Oh man, this is so AIDS.
Uh, okay, yeah, that should work. Um,
Oh man.
think, yeah, this is just brute force, I believe.
Maybe the difficulty is just in implementing this shit.
It's not even that hard to implement, I don't think.
I don't know.
Um,
I'm struggling. uh, wait, maybe I should just do this. Oh man, but this is gonna be so bad. Oh. Hmm. Oh wait. Hmm. Okay, my brute force worked on the test case.
uh,
uh,
yeah,
but I think LTLE.
that's a lot of loops, man.
It's a four times nested loop. It's so bad.
That's your shit's gonna blow up to like a trillion. Pass most, but TLE, yeah.
Hey, it works. It works. But did you get a working solution?
No, I'm not done implementing yet.
Oh man, how do I make it not TLE? Fuck. Oh, what clever sorcery did you use?
1, 3, okay.
Fuck.
Why is this TLE?
This?
No, why is mine TLE?
Oh, fuck. How
It
do
should be
I
n squared. It's 1000. It has to be n squared.
n squared? Your solution's n squared. Damn. Mine is not n squared.
I think it's n squared. Yeah, it should be n squared.
I think mine's n squared squared.
Yeah, well, at least I know this works.
Uh, fuck.
Mine is just like basically just bucketing them and then matching up the pairs.
Bucketing them.
Yeah, I just have a hash map.
Ah, wait a
Easiest
minute.
product. Then just bucket
Uh,
them and then pair them up. But like that's still TLEs somehow, even though it's n squared, I think.
oh. Hmm. Okay, your n squared is for matching every number together,
Yeah.
every pair together. Oh, okay.
Yeah, but then I do another pass over the pairs.
Yeah, so you can find
But
its match.
it should work. Although I guess it if
Okay.
every number is the same, then I have like
Hmm. Is it also n squared for the matching in your hash map?
ooh, that's a good question.
So
Uh,
it's n squared plus n squared, right? Because you gotta look.
no, actually, yeah, it's actually n to the 4. That's why it's too slow.
Oh, it's the matching is n to the 4.
No, because if you bucket them and they're imagine if the edge case where they're all the same. Like imagine if you have the numbers, if you have an array of numbers, they're all the same, so they all have the same product when pairs. So then you get O of n squared pairs in your hash map. But then if you brute force match them,
Oh,
that's
okay. It's n.
another
Yeah,
O of n squared
you're n
n to the
squaring the n
4.
square results. Ah, yeah, you're
Yeah.
right. Damn,
I need a way to do it linear time.
matching
Or
a linear time. Yeah, how the fuck do you do
yeah,
that? Wait, so pairs, you're storing them as tuples, right? I'm guessing of index.
yeah.
And the valid ones would be where uh the first index is at least plus two, and the second index is plus two of the second one. And is there a fast way of
E
finding those? What if they were ordered? Uh, if they were ordered,
Ooh, yes. You're onto something.
you could find like for the first one, the plus twos, that you could find it with what binary search, and then from
Mm,
those ones, I mean, would it be that much faster? For the small index, it wouldn't be. Wait, you'd order it by the first and second. Oh, you want the first one to be at least plus two with the first one and at least plus two with the second one. And then everything that's after, since it's ordered by first and second, everything after should still be valid, right? As pairs.
yes, this is binary search, I believe.
Yeah, so,
Uh,
and then it goes linear from there until it doesn't match anymore. Or, or, because it's ordered by I and J where I is prioritized.
yes. Well, you
And
can get
then,
it down. If you do it that way, then you can get it down to like n squared log n. Um,
yeah, maybe that's a way. So you'd have to sort your hash map. So what is that a sorted list?
mm, uh,
I'll start by implementing the matching first. What do you think about it? PQRS has a gap of 1 between each 1, 2. This next element 0, 1, 2, 3, 4.
And then I need some paper for this. This is hard.
Yeah, this is hard. 2, 6, is it here? Yeah. Wait, for your pairing, did you do I plus 4 and your in your inner loop? Range of I plus
Yeah.
4 to n? Yeah, okay.
Yep.
I was wondering if you did
But
that, if the brute force would be faster and you could pass.
no, you need to do that to generate valid pairs.
Yeah, because I thought maybe in your n squared matchmaking you'd take care of it there. So you have uh 0, 4. Wait, are they already in? Okay, but dictionary doesn't keep the ordering. Wait, is there a way to store them? Because you already know they're gonna be unique, so you don't need to make it a hash map. You could store them in an array, and they're gonna be already sorted in the array with the way that we're generating it, right?
No, your map is backwards. I'm doing product to list of pairs.
Okay. Oh, true, 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 true. Because you're looking for. Oh, but my idea was to look for every valid indices and then see if the pair was equal. Is that cringe? Wait, no. Instead,
Well, you're making it a lot harder for
yeah,
yourself. You
you're
can just
making it harder. You can
if
find.
you you can first bucket all of the pairs, and then it just reduces to the problem of matching the pairs that don't
Oh, yeah,
that
yeah, yeah, yeah.
overlap sufficiently.
Oh, and that TL lead.
Yeah.
What? Oh, okay. You say, yeah. I see what you mean by the worst cases. All of them are the same. Are all
So you
in the
get
same
n squared
bucket.
pairs. You get O of n squared pairs in your hash map bucket,
Yeah,
and
and then
then
it's trying to match to all of them.
so then becomes, and then that becomes like O of n cubed, I think. No, or O of n to the 4.
Yeah, but so your bucket is an array, right?
Yeah.
And the way that you're generating them, the bucket should already be sorted.
Yes, you're actually right. I don't need to sort it.
Yeah, you don't need to sort it.
Um,
Uh,
I can.
J.
How do I binary search this? I can binary search.
You can do bisect left, and you
Yeah,
give
I
it
know, but
a
like I'm trying to find a strategy for binary searching the correct point.
because you want to find the first occurrence of I plus 2, right? And then the moment that the first index is getting too close to so the first index would be Q, right? The moment that Q gets too close to R, that's when you stop.
Yeah, I know, but like I'm trying to like, cause I think I need to do two binary searches. I need to find the first where the start is 2 greater than the like the first, then P, and then I also need to make sure that the end is. So I need to make sure that like I'm finding pairs that are where the start is between E and R, like sufficiently far. So like +2, -2, and then the end is also
Hmm.
Then the end is +2.
Yeah.
Uh,
Oh. Hmm. Guess in each one you're matchmaking. If you had like 0 and like a million, you could still have 2 and something small. Fuck. Hmm. Damn. It's crazy. 103 accepted, 1.3k tried. Have a product.
is it still more people? Yeah, more people is still like the success rate on Q4 is way higher than Q3.
Yeah. Do you think we should check out Q4?
I'm gonna let Q3 simmer. I'm gonna try Q4. It seems
Okay.
like accounting. This is a counting problem.
Count the number of arrays with k matching adjacent elements. NMK, good array.
Like n is n 10 to the 5, so it has to be linear time. Um,
Each
although
element
the
in here.
craziest this type of shit, you can probably just work out a math solution to this. Like I wouldn't be surprised if there's one formula for this type of problem.
I'm still reading it. Each element in array is in the inclusive range 1 to m. Okay. Exactly k indices I, where I is between 1 and n. So that is okay. So this k indices. Wait. I is between 1 and n. So n gives you like the limit where to search. Wait, I don't get it. Array I minus 1 is equal to array I. So the element coming before is equal to the current element. Wait, exactly k indices I, where I is between 1 and n. Wait, for example 2, n is 4, but m goes to 2.
Hmm?
So like for n equals like 4, does it do anything? Because
N is the size of the array.
n is this
N is the size of the array.
isn't
M
m.
is like the maximum, is the upper bound on the on the elements. And then you can have basically you can have k steps. No wait, you can have yeah, you can have exactly k places where the elements are the same, I guess.
Wait, oh wait. Okay, any like the elements in array is anything between 1 and m.
Yeah.
Okay. Oh, okay, I see. Oh, I get it, I get it. Exactly k indices I satisfy this condition. What the fuck?
This is combinatorics.
So if k is equals
Uh,
1, you just need...
say you start 1.
Okay, so for k equals 1, it just means that there's 2 places where they're equal. and then all the others can be anything, right?
Yeah. So
So k equals 2, there's two cases.
exactly.
There's either like it's 3 consecutive, or it's like 2 separate consecutives, right?
Uh,
Yeah, so like 1112 is the example of 3 consecutives, and then 1122 is the example of 2 separate consecutives.
yeah. One
Okay,
one two two.
so
Was yeah.
let's.
It's just like 1112. Yeah, yeah, yeah. That's like the single string, but like the total number of consecutives is exactly k. So
Yeah, because here you have either you could do like XXX and then anything, or like, or you can have like X, 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 and then here it's free, let's call it O, and then this X can be 1 or 2, and then this O can also be 1 or 2, right? So that's one case, so that
okay.
there's 4 ways of this one, and the other one would be like X, X, O, O, right? There's
Yeah.
two, wait, is this? Oh, but there's also overlap between these two sets, right? Because the overlap would be like 1, 1, 1, 1, 1, 1, 1, 1. Wait, is this a possible solution? 1, 2, 3, 4, 5,
Well,
6.
no, 1111 will be x x x
Oh,
x.
true. It has to be exactly. So it excludes that from the possible ways of doing it. So there's not actually 4 ways of doing it. If you pick 1, this would be 2. And if you pick 2, this would be 1. So there's 2 ways of doing it this way, right?
Yeah.
And is it the same thing here? Wait, but then I'm missing a case, no? Here it could be 1 and 2, 2 and 1. So that also makes 2 ways. But then I'm missing another 2 ways. Oh, the other way would be OXXX. And this is also 2 ways. Oh, but that's not generalizable. Oh man, that's cursed. So that's for the, yeah, so that's case oh, and there's another special condition for when they're longer, because it has to be exactly K.
Yeah.
So then you would have to exclude, like if it was longer than length 4.
This feels like it feels like it'd be perfect for like DP or like um or just like DFS, but like the problem is that it's 10 to the 5, so it has to be linear time
Yeah.
in n. I was gonna go at this from like a combinatorics standpoint. Uh,
Man.
yeah, well, if you start with
I do not allow anything in the form like this. 1, 2, 3, because you'd have 3 in this case.
I'm thinking about this one element at a time. Okay, so for the first element, you have m choices exactly. You can so let's say well, in the first example, m equals 2, so you can pick 1 or 2. Okay, so
Mm-hmm.
then for the next number, you can either choose to make it the same or make it different.
So there's like two branches.
Yeah.
So if you take the same, so then you'd have like, so it's either it goes like XX or XO here.
Yeah.
So that this is only like a multiplier of one here, right? Or well, let's use numbers here. So it is like
Oh yeah,
NA.
you either take the same, or you can pick any of the other m minus.
Yeah, so if you take the same, there's only one way. Like it's a times one, and here it'd be a times n minus one, right?
One a.
And then here you have two consecutives already. It's again the same choice here, right?
Which is which has one.
So that this is one way, and this is n minus one, right? And then here, wait, what the fuck? How does this guy know me? There's someone that wrote in the chat, are you the guy that interned at Autodesk and SAP? Who are you? Tiramisu Tank. We spoke before, but I don't know you by this name.
Maybe it is DP. Can I express this recursively?
Wait, but then here, like if we take like XO, we can retake X, we can retake O, or there can be a third element, right? I don't work right now.
If you pick a different element, the number of choices is always m minus one.
Well, here it'd be m minus 2, no? Because then you're taking a completely different one.
No, you can go back to x if you want.
I mean, here I went back to X. You have like either you go back to X, either you retake O, you gotta take another one, and I'm running out of creative juice. I called it Z. Right? Because you still have the option here of taking a whole different one, right?
Mm. Uh,
Oh, and you can also.
I'm gonna try DP. I'm gonna try DP. I don't know if this is linear, because I can't see another way to do this in linear time.
Hmm.
This seems if DP works, this question is really easy.
Hmm.
Minus one.
Oh, I think I see the DP kind of. Okay, once you have two consecutive, then you have to make sure that every time they're different.
Count.
Hmm.
Same equals.
Hmm. Uh, Hmm.
Okay.
Wait.
If n equals k, return 1. Yes, that is correct. Wait.
Uh, wait. Okay.
If n equals k, if n
I need more than this.
plus 1, yeah,
Uh,
is the same, then it's just that. Otherwise, it's n minus 1 times
mm,
same positive 2.
uh,
Hmm.
hmm. Fuck. Hmm. Is it the same or is it different than the previous one? Uh,
4, 6, 2.
hmm.
There's no way this works, but whatever. Wrong answer, yeah.
How do I know if I'm taking a different one? Oh, there's two ways. It's either it's the same one or it's a different one than the previous one. Uh, damn. Someone in my chat solved Q4. Big brained. The count would be. So if count goes up by one, it's because I took the same way to someone. Same one, so the number way stays the same. The other way would be that count is not increased, it means I took a different one. And the number of ways to take a different one is m minus 1, but the
K
current.
equals 0.
Fuck. The number is minus 1. There's no way.
I'm so close.
No. Uh, the approach I'm trying to do is at every step you're choosing either you're taking the same element that's as the previous one or you're taking a different one.
Yeah, me too.
And I'm doing like DFS plus the other DFS depending on if you pick the same or different one. Oh wait,
Yeah. We're doing the same thing, basically.
okay. Oh wait, but that's num ways minus 1 times num ways. Is this it? I don't fucking know. No. Wait, is it because I don't? Oh, I don't think I'm base casing. Uh, okay. Yeah, that's why if count equals to k, return num ways. Yes. Oh, wait, 6? No, that's for case. Oh no, it's supposed to be 4. 12, 2. Okay, that's not good. No, someone's writing solution in chat. I'm not gonna look at it. Yeah, for the first one, we have m m selections and the number of
First one has M.
consecutive. Yeah,
The next one has
depending on if
M
you take the
minus.
same. So if you take the
Yes.
same, the count goes up by 1, and then we stay within the same number of ways of doing it. If we take a different one, then the count doesn't increase. And now there's num ways times num ways minus 1. Because you picked anything other than the current one. Is that correct? Wait, let's test it. Because in the case where we have 1 and 2, so here I'm saying there's 2 ways. And then here, there's 2 ways of doing this. XO, there's 2 ways as well. Because the other choices, there's one. If I take one, the other one has to be 2. So there's also 2 ways of doing this. Because it's 1, 1 or 2, 2 here. Here's 1, 1, 1, 2 or 2, 1. Okay. 2 ways of doing this. Also 2 ways of doing this.
Four, six,
Oh man, still
2,
can't sit the right out.
3. Okay, that's not right. If
What
n equals 2,
what's your
it
output for
gives
the first
3.
one?
Oh, it's 4.
You have 4 for your first one. Damn.
Yeah.
Mine's outputting 6. If count is greater than k. Okay, if we reach the end.
Times n.
Oh, is there a chance I'm double counting? Because if I have x or x or x or z. Oh man, I don't know.
N equals k plus 1. Oh, then it's return m.
Hmm. And oh wait, no, that's cringe. I can't do that. Okay, I figured out why it's bad. Okay, so here the number of ways stays the same, but that's not num ways times minus 1. That's actually m minus 1 here. No, it's still wrong. Fuck. I'm taking a different element. Number of ways times a different element, so it's m minus 1. One, there's 2 ways.
Oh, but
There's 2 ways. 3. 1, 2, and the third one. Wait, how many times is that gonna run? Same, I'm gonna run too many times. Okay, now I have 4. I think I ran it too many times, maybe. 4, 6, 2. So yours works with the test case?
I changed it now, it doesn't work anymore.
Okay, mine works with the test case, but I don't think it'll work. Oh, and you have to mod. Wait, is it just a mod that I'm missing, maybe? Watch it load. Okay. Wait. Oh, wait, okay, that works. Oh, I got memory limit exceeded. Did you hit the same
Oh,
issue?
really?
Yeah.
No, I'm still trying to figure out the implementation.
Yeah. So I think mine works is just memory limit right now.
Maybe you have to do it bottom up instead.
Bottom up? No fucking way. Wait, you're getting TLE or memory MLE?
I'm still trying to figure it out.
No, I meant like someone in the chat said like test case 554 TLE. I'm doubting TLE.
It's not DLE, it's fucking MLE, dude.
Yeah, bro. Man. Wait, maybe the caching is struggling because of my numways. What
Oh
if
yeah, that's for sure. That's for sure.
instead of having this shit, it should be returning the multiplier instead of keeping track of how many I'm at currently, right? Fuck, man. This is so cringe.
N equals.
Wait, how do I keep track of the current number of ways and then I can multiply by the DFS instead and then the caching is going to be better? Uh, yeah, because it should be returning to me the multiplier. So in essence, I actually want, let's say we have the fuck, it's not num ways, is it? Oh no, let's just try this. It should be something like this, like this. Wait, no, that doesn't work. Wait, wait. M minus one.
4, 6, 2, 6. Did I do it?
You got it?
Did I do it?
Did you do it?
Well, let's see.
Damn.
Well, we'll see. Memory limit exceeded. Fuck my life.
554?
555.
Oh, 555. That's crazy.
Fuck my life, dude.
Yeah, I'm trying to find a way if I can take out this num ways of my DFS. And then maybe this would allow the caching to work. Because yeah,
Nah, even without it, it doesn't work. I
what?
don't have them without. I
What
do
the
it normally recursively. Like the only two in my cache are the N and K.
man,
Fuck my life, dude.
fuck me, man. Wait, fuck. So there's M ways? Oh my god. Wait, what does this DFS count if I do it this way? Okay, yeah, so if I reach the end of the count. Wait, fuck. What does it return here then? It should count the number of ways of what? Fuck. Man, how do you do it without number ways?
You just you don't accumulate it.
Yeah,
Just
I don't know how to not accumulate it.
just take the result. You just define your base cases and then
It a
I think
bit.
you have to do it to bottom up though. This shit is dumb as hell.
You have to bottom up. Fuck.
Um,
Wait, what's the base? If count equals to k, we reach the end and count is equals to k. And what's that base case? Does that mean I found one way of doing it? Man, I'm so ass at recursion. Keep accumulating this. Oh, okay. I think it's just like this. Wait. It's like this.
Even
Nah,
bottom up, it wouldn't work. We're just doing it wrong.
man.
It's like I
Depression.
tried initializing a fucking array that big, it just runs out of memory. My god.
Oh no, that wouldn't work. No, wait, that's one.
I give up on that question. I'll go back to Q3.
4, 6, 2, and wait. No, it was this one. Where's my wrong answer though? I want to see the wrong answer. Oh, I forgot to mod it. Fuck. Wait. Wait, numways never changes here though. Wait. Wait, so that's just always M here. If it never changes.
I'm so ass at contests, dude. Questions are so hard.
Yeah. Maybe just dailies are easy compared to these, maybe. I don't know.
Yeah, they are. They are, dude.
No, but that would still cause the TLE, the MLE. So I really have no choice but to uh fucking bottom up.
No, bottom up even doesn't work either. I think you need the DP to be of one variable. Of how you do that, I have no fucking clue.
One variable ain't no fucking way. Oh man, this is so cringe. Wait, you reach the end, and if you're able to reach the end, then you have M, and there's two branches. It's either increments or it doesn't increment. Wait, can you do this with math? Man, it's cock and ball torture. You sure even bottom up? It doesn't work.
No, bottom up, you run out of memory also.
You tried it, or how do you know?
Yeah,
Oh, you
because
wrote
I
it?
tried initializing an array that would be the same size as what the cache does, and it just ran out of memory.
Oh, okay, I see. So do you have to solve it with math? Because
I think so.
I don't think there's a way of doing it without
There's probably some O of one math formula that just gives you the answer straight up.
yeah. So at every branch you have the decision. Either you pick the same one or you pick a different one. If you pick a different one,
This is correct. Like
yeah,
the solution is correct. It's just too
yeah,
slow and also takes up too much space.
yeah, fuck. C'est difficile. And then for Q3, you think Oh my god, the stats are so horrible. It's like a 10%, less than 10% acceptance. That's over on like 10% of user tried succeeded, but on submissions it's even worse.
I think I know what the answer is for Q3, but I don't know how to implement it.
Oh wait, so
Because
here,
if you think about it, the second step, okay, the first step you construct all the intervals, like all the pairs,
but
right?
I think there might be a math solution hidden here somewhere. So here, count goes up by one. Like in this way, we want to know the number of ways we can get count to go up by one, and then it has to be equal to k at the end. So that there's k ways, right, of doing this.
I'll send you
And
my solution after I'll send you what my code was after the contest ends.
okay,
Um, but going back to Q3, like if you think about it, you construct a list of intervals for each product, and then question two, you're just asking within each um within each list of intervals, how many overlaps are there? That's basically what you're asking.
for Q3, how many overlaps? So you're
Yeah.
taking like the pairs as like a range,
Yeah, because
and
they
and
have to
then
overlap, right?
you yeah, they have to overlap, and but they have to overlap in a specific way, such that
By one. So you can just check it like that. It's probably annoying to implement, but that's my idea.
you think it's like a sweep algorithm.
Yeah, like a line sweep type of deal.
Oh, oh, I can see that.
I think that's why this question no one's fucking getting it.
Yeah, fuck that. I don't feel. Wait, so here, count plus one. How many ways of doing count plus one until it's exactly k? There's k ways, and each of them gives me m. Uh, wait, DFS I plus one, count plus one. So m times k here. M times k is 2. So it's m times k plus something else. So here, how many ways? Oh, that's if you only do this. No, no, fuck, it doesn't work. Because you have to not, not increment count. And if you don't increment count, it does this instead. So every time you have the choice of either picking the same or not picking the same. And if you don't pick the same, you have m minus 1 ways of doing that. Fuck. Hmm. Man. If it reaches the end, count all the ways of doing it. Oh, what the fuck? Okay, maybe. No.
Okay, like I think the sweep line would work. I just don't know how to implement it with the fucking well, at least one element between each pair rule.
I can't factorize this. Oh man, I don't know.
Two out of four Andy once again.
Yeah, man, contests are
Just hard.
rough. Shit's hard. When you do dailies, when you look at it and you don't know what to do you go look at like topics or hints sometimes or not?
Topics first, and then hints, and then editorial.
Yeah. Do you think it's because you don't have access to that that makes contests feel rough?
Yeah. Although usually I don't need to, unless it's a hard.
Yeah. Because,
It's
yeah,
the only
sometimes
question
I look at
a lot.
it and I'm just too lazy to think, so then I go look at like topics and then I don't really look at hints. I mean, sometimes I'll look at a few hints or then I'll just check editorial or neat code.
So you get to the end of the hints, it literally just tells you how to do the question. Like,
Oh, sometimes I look at hints and I still don't get it. It's crazy how 50% acceptance, 50% of the user that tried got Q4
how do you do it in linear time? I don't get it.
in linear time.
Yeah.
Man, I wouldn't know how. You think it's a one variable DP?
Either that or fucking O of one math formula. Like,
Damn, time's up. Let's check contest
yeah,
rating.
it's hard.
Yeah, it was rough. It was rough. I
This is what
completed
I had.
29 minutes now, faster than last contest. Wait, but did I troll Q2? I think I did troll Q2, right? Yeah, I added 10 minutes. Oh, okay, else it would have been 19 minutes. Oh, my rank is pretty good.
2000? Wait, what?
1,900. And
Hold
I,
on.
if I didn't troll Q2 as
Oh, my,
much,
my
it
rank
would,
is 1500. That's not that bad, actually.
it's actually
I
pretty
guess this is
good.
a hard contest.
Yeah, I think
This
it's
is a
just a
hard contest.
damn, cost me 10 minutes to troll. But yeah, I fell into the same edge case of the one. And then how did I troll again? Oh, and then I messed up the math for like where to end the substring.
Yeah.
Oh well, pretty good result if you think about it, you know. I feel like contests are just getting harder every time. Like just looking at the threes the four that I did. Oh no, the first one was pretty
Yeah.
rough that I did. It involved like rectangles and geometry in a graph. It was annoying, but pretty good, pretty good. My finish times are getting faster at least.
Think, how do you even sweep line the fucking question three? I feel like it is sweep line.
You
Because
think
like
it's sweep line?
if you can just
Sweep line means that
once you build the pairs, then it's just
because
counting overlaps.
sweep lines you just keep track of like start and end, right? In a single array.
When so like yeah, you can think of the lines as like when it like a yeah like a line sweeping across. If you imagine like the intervals on like the XY plane or something, imagine a line sweeping across like the x-axis or something, right? Like a
Yeah.
vertical line.
So let's say you had like intervals like this, or I don't know, like let's take this as an example, I guess. You sweep the line first, you'll hit this one, right? So this would say
Yeah.
there's like
Yeah,
a,
so you store them in like a tree or something or like some kind of map.
isn't it like in the list you have to start and the end? So like this one, let's say it starts at 0, 1, 3.
Yeah, well the you require that they're sorted first, right? So
Yeah,
you traverse them like from left to right. But like when you hit the start point, then you add it to like your structure that holds the ones that are currently alive. Basically, they become alive when you hit the start and they die when you hit the end.
yeah,
Like at any given point, all of the intervals inside of whatever data structure you're using for to hold them, probably a tree, um, are all overlapping.
So you hit this
They
one
all
and
have to intersect the line.
so then this one would set this one as alive, right?
Yeah. Then maybe it's not sweep line, because then if you have like the fucking intervals inside of each other, then
Oh, because
that
then you
doesn't
could
work.
have, if you have two that are alive, then you have to check everything, like if, like which ones are corresponding to these ones, right? So, so
Yeah.
you have to check like if it's valid with every single alive one.
Yeah, okay, yeah, maybe it doesn't work then. I have no
But
idea
at the
then.
same time, you know that the alive are sorted, so you can find like the latest one, like the last one that is like illegible, and then everything before is also
Maybe you sweep line and then plus binary search. This seems way too much work for a medium question.
yeah. I mean, you can look at the solutions that people submitted to
Yeah,
get an
let's
idea.
see.
Oh, I don't understand what he wrote. Oh, what the fuck? There's GCD and LCM. What the fuck?
Oh, that makes sense. Yeah.
I don't get it. Wait.
Yours is backwards. Okay, I don't understand this one either.
Oh, I don't get it. Ratio. They're doing division instead.
I think
PQ.
it's kind of like two sum. It's kind of like two sum almost.
Wait, ratio R and S. Oh, what? Are they inverting the equation? Because it's like it's PQRS, and you know that P times R is equals to Q times S. So if you want them consecutive, then you could do like P over Q is equal to R over S,
Yeah.
S over R. Then this way you could like group them consecutively like that. Is that the idea?
Mm, if PR equals QS, then
PQ equals SR. Wait, yeah, SR.
oh, then P equals Q. P over Q equals S over R. It's so. Oh my God,
Yeah. And then is it just two sum at that,
dude.
or is it just two sum after that?
Yes, it's two sum except you need to make sure that P and Q are at least one apart.
Yeah, so how did they do that? Oh, yeah. Yeah, so your Q candidates, you can like pre-compute them. Wait, they pick their R's first. They start with R, they go backwards. And for S,
Because S and R
oh,
have to be greater
okay.
than P
Yeah,
and
so
Q.
you're checking for every valid candidate S, so you just start from S, R plus 2.
R minus, yeah, R plus.
Because it's
Wait, what?
after. S comes
Oh, yeah,
after
yeah,
R,
yeah, yeah.
yeah.
Yes, yes, yes.
So these are all the valid ones. And then Q is, wait, Q equals R minus 2. So you're just taking the
Yeah,
first one?
because it has to be one apart. Dude, that's so easy.
Wait,
Fuck.
but why is it just taking a single Q? Could there not be other
What do you
options
mean?
for Q?
Uh,
Could like R minus 3 is also a valid candidate, no?
trying to think. Why is that correct? Wait, yeah, you're right.
That doesn't make sense here. And then P in range of Q minus 1. Okay, so but it's exclusive, so that makes sense. So P is selected relative to Q. So everything makes sense except this Q equals R minus 2 to me.
Yeah, why? Because I feel like, because like otherwise, like if you did loop over all Qs, would you count something twice?
Ratio equals this. Map ratio plus equals 1, yeah. Q over P. Okay, they did it the inverse. And then ret is answer. Okay, the answer is plus equals map. Okay, so everything that map matches. Wait, here R over S. Okay, they did R over S here. And then Q over, okay, so they just did the opposite. Instead of P over Q, S over R, they did R over S, Q over P. That's the same idea.
Yeah. Why is it Q minus 2?
That I don't know.
Wait. R minus 2. Oh, wait, no, I get it. Do I? Wait, do I get it?
Do you get it?
Do I get it?
Philosophical
No,
question.
because, okay, so we know that Q has to be in the range. Wait, PQRS. No, wait, I'm stupid. No, I still don't get it.
Unless there's a condition that says that there must be exactly one apart. No, it's at least one
No,
between R and Q.
let me look at the question again. Okay, so P less than Q less than R less than S.
Is there a counterexample that we can come up to this?
Well, obviously there's no counterexample because it passes, right?
I mean,
But
maybe the test cases are missing something. That's what I mean. Like, could we create a
uh,
test case that would fail, is what I'm asking.
so what does this check? It checks, okay, it checks for all R for in the end, and then
So
uh,
here we have one,
oh, R
two,
is the middle one.
2, 3, 4, 3, 6, 1. Okay, and here there's one way, and that's 0, 2, 4, 6. 0, 2, 3, 4, and 6. Can I generate another way that would contradict this claim? What if this was 1? Not because this, wait, this would cause an issue, right? Could I have this and this?
Oh wait, no, I get it. I get it. Yeah, that's correct. It's correct. There's no counterexample.
Why is it correct?
Because you're just counting the number of pairs that have that ratio, right? You're counting backwards.
Yeah.
And then every time you find a pair with the same ratio, you just add the number of previous pairs you already saw
Wait. Oh,
with the
like,
same ratio.
wait, map inverse. Oh, wait, but this ratio, number of. So these are matches where S and R are valid, right?
Huh?
So,
Yeah.
like, in the map, it's the number of matches that you got between S and R. And then when P and Q are compatible, then you're adding the
So
number.
if you think about it, like if you is it you need to like when you're iterating backwards, you only need to check the ones like strictly because like okay, so if you checked all Q, then every time you found a matching pair, you just add one.
Mm-hmm.
But here they map they add the number of pairs with that ratio that they've already found. So like because like if you slide like the window left, then how do I explain this? Then like this.
Wait, I'll try to generate a counterexample and see if it helps me understand.
I see why it works, but I have a hard time explaining it.
Yeah, maybe I can try to prove it by, like, try to prove myself by contradiction. So here it'd be 0, 1, 2, 3, 4, 5, 6, 7. So that's one way. And the other way would be 1, 3, 5, 7. Wait. Oh no, this wouldn't contradict it. I actually need this gap here to increase. So what if instead uh, oops.
Okay, I see how to explain this now. Okay, um, maybe I can share.
Wait, I want to try this first. 0, 1, 2, 3, 4, 5, 6, 7. And the other way would be this, and this. 0, 3, 5, 7. So here, this is like where I see the gap between P and Q. I mean R and S. Q and R, because it's P, Q, R, S. It missed this one, right?
Well, you can try it.
Wait, but the
Just put in
thing
the
is
array.
ratio for S in range of blah 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 ratio. Wait, fuck. Huh?
I think what the solution does is that when
Okay, I
when
can
you're
share your
because you're
screen.
iterating over all R, because you're iterating over all R, then you don't need to check all the queues for each R, because you'll have counted all of the like associated pairs on the right already.
Like R
So
and
you can just
S,
add,
all the ways to R and
yeah.
S. And here it says there's like 2 ways of R and S.
Um, Hold on.
I don't get it.
So let's just walk through it, I guess. So here it'll count, it'll find like, okay, so for 3 there's
Okay.
1.
So it find
For
2. Well, here it finds 3 ways, right? Of doing this ratio.
it finds 3. Is that right?
Because 1, 3,
Is it 3?
1, 3. There's yeah, I'd see these 3 ways, right?
Yeah.
So
But there's
then
only 2 ways.
the like for in the dictionary the ratio is R over S. So R over S is 1/3, right? And that has a value of 3, right?
Oh no, R over S is 3 because R is the one on the left.
Oh, you're right. So it'd be 3. And there's 3 ways, right?
Yeah.
And then it's trying to encounter a Q over P that's also equals to 3, right? So Q over P. So there's only this one that's exists, right? Where the gap is 2. And then this one would associate with that one. So the answer would be, now the answer would be equals to 3, right? For this.
Wait. For 3?
So for 3, for the map at ratio, the ratio of 3,
We need
there's 3 ways,
no, we
right?
need P over Q. We need P over Q equals
Q,
S divided by R. Oh
Q
yes.
over P.
So
So Q over P for any.
Q over P, yeah.
So R is the third number. So let's wait. Oh, it depends on which R we're talking about as well. Because there's this R and then there's this R, right? But only this R would give us a valid Q, right?
Isn't this answer just 1?
Does it give just one? Oh, is there just one way? Isn't there
Try it.
2 ways?
Just try it. Just try it. Just try it.
Okay.
Because it'll tell you what the expected is, I think.
3, 4,
19334
3,
36.
6, 1. There's two ways.
Oh, it's two. There's
Okay,
two.
because I have them here. Two ways.
0, 2. Okay, yeah, you're right. You're right. You're right.
Because I constructed it.
Okay, so let's walk through it. So from the end, it starts. No, it actually starts from like
Yeah, because it goes
here,
backwards.
but it starts at -1, but it should actually start at like -3. Um,
Because it goes backwards,
yeah,
the R. So this is the first three
yeah,
that's gonna find. But then the ratios
yeah.
is actually three. This is the map currently, right?
It's
Three
gonna be
one.
1. Yeah,
And then this
it's
is
gonna
gonna
walk
match to
backwards
that one.
again.
Yeah, so then currently the
Yeah,
answer is set as 1, right? For this iteration. And then when it gets here, now the map is set to 2, right? There's two ways. Wait,
wait.
yeah, now there's two ways, right? Is there two ways? But it's still one. Oh, well, it's plus equals 1. So it found another way of doing it like this, right?
Yeah,
So now the map is set to 2 here, right?
2.
And then it goes,
Yes.
Q equals R minus 2, so it goes to this one, right? But this one, there's no matches backwards. Wait, what?
Wait.
So that's set to 2. So
No,
this
no, no,
one,
no. Wait, wait. Because I get it. I get it now. Like the map at that point is how many pairs to the right have like the inverse ratio, like have that ratio.
yeah, so well, when R is set
So
here,
find.
the map is
So it would
currently
find.
3-1, right?
Yeah. So Q it checks R minus 2,
So Q is
right?
here, right?
So then it adds 1 because it does another loop and finds the 3 and 1 pair. So then it adds
Yeah,
1.
so adds 1, so answer is set to
And
1
then
here,
and
right?
then on the next iteration, when R is set to 1 left, it'll find the other 3 1 pair and match it to
When it's
that.
set here or here?
Yeah. To the 4, yeah.
At the 4? How does it find them?
Because it's just R minus 2.
R minus 2 is
It's
here,
just
right?
R minus 2, and the 3 is still the 3 is still in the map.
Oh, oh, because the ratio is still there. Oh, wait. So
Well, the
this,
3 like the 3 they keep track of all of the ratios in the map. So the 3 1 pair, the 3 1 mapping is still there.
wait, so this R, like this R is not the actual R that's being used.
No,
Oh,
it's
what the
just a pointer that moves left.
yo,
But
that's
like
so.
at the current point, it is the R that's being used. But then you
Like, but
basically
it,
store all of the possible R's in the map.
yeah,
You just
because
store a count of them.
I thought like the PQRS would be like 1 3, well, not the index, well, the values at PQRS would be 1 3 4 1, and I'd be like, what the fuck? How does this work?
No,
But
but like the
like
3-1, the 3-1,
it's like
it, it
tracked in
it like
the,
matches to that. It tracks in the like the 3-1 corresponds to the 5-7 in your answers.
yeah. So the R here, it's used to remember.
It's basically just a pointer that moves left.
Yeah, it's a pointer that moves left, but it's not like it's not the actual R that's like currently used. It's just used to like remember stuff in
But
the
like the map,
yeah,
the map basically stores all the counts.
yeah, it's a map that stores all the count. But like here when it like it goes and finds the inverse. It's not using like the current R that we're at.
Yeah. Basically like the pair. Okay, like basically like the map just stores how many pairs to the right
Yeah,
of the current index have this
that
ratio.
yeah.
So then as R moves left, you can just set Q you can just set Q to like R minus 2, right? And then check all of the S's. You can check all the P's before Q
Yeah, you
because
do you
it'll
do
it'll
Q
just sweep
minus
across the entire array.
yeah, you're doing Q minus 2 because like what if it's a current R that's being used?
Yeah. Well, yeah. Because
Yeah,
you can't
because
because
if it was the
you're only counting from R. So like
yeah,
any
anything to the right.
pair that comes before has to be R minus two.
So the only ones valid would be anything r minus two for this current what's
Yeah.
currently inside
And then
the map.
all the p's would just be up to q minus two. So then you iterate all over all those pairs.
Oh man, that's so fucking big brained.
Yeah, that's a hard question. The less
Yeah,
people solve that than question four.
yeah. Okay, yeah, I get it now. I get it now. But I see why it's hard to explain. Wait, so how the fuck
Yeah.
did people do
It's,
Q4?
I
I
need
don't,
to know. I need
check
to know,
check
dude.
check number 15. They're called Python is the best language.
Let's show me this all. Wanna see? What the
What the
fuck is
fuck?
this?
Yo, this is cursed. What
Combinatorics? There's probably like their fucking like they have a library that they or something.
the
Okay, check another solution.
yeah.
This is bullshit.
How about Grimoire? That's fucking China. Grimoire Emerald. What the fuck?
Yeah, I told you it's all one math. Fuck my life, dude. M times math.com times pow.
So that's combinations, right? So it's n minus one choose k. Is that it for this?
Wait,
What does pow do? Is it just exponents?
yeah. Okay, so it's M times. How does that work?
Is the n minus one choose k?
Yeah, n minus one choose k. You're right. Yeah, it is.
Okay, so it's n times n minus one choose k, and then what's pow? Is it m minus one to the power of n minus one minus k?
Yeah,
And is that a
and then
modulo
a
or
modulo. That's a yeah. Python's pow has modulo
built in?
optional argument.
Okay,
Yeah,
so it's m minus one to the power of n
and
minus one
n
minus.
minus one minus k. I told you there's gonna be some fucking math formula for this, dude.
Yeah. Okay, so this is it. What the
Yeah, no, the left term is m. It's m times n minus one
what
choose k.
yeah. What the fuck? Yeah, I mean, I kind of saw it. Like there was a math way of doing it, but I couldn't figure it out. Okay,
Wait,
n
hold on. Go
minus.
back to the code.
I basically
Okay,
wrote
yeah,
it in math
that's
notation now.
yeah, that's correct. Okay, so
N minus one choose k. What was k again? Oh, it's the number, like number of consecutives that we want, right?
yeah,
N minus one is the length. It's the length of the array, or is wait,
wait, n
what
minus
size n?
one.
Choose k. So why are we
So
choosing
k is
k?
the number of consecutives you need.
Yeah,
I'm thinking of this. Okay, I think it's more like you place your consecutives, and then in you need to figure out how many different ways there are to place your consecutives.
yeah.
It doesn't matter what number it is,
Why is it n
because
minus
it's
one instead of n? Yeah,
a good question. Like it can be any number that's consecutive, right? So then it's just I
yeah,
assume n minus one choose k is like the number of ways to pick that, and then you multiply by m, and then you need to fill in the gaps. So
yeah,
it's
yeah.
n. So like
Okay.
it's n minus one minus k, which are the gaps, and then for those you have m minus one choices
Oh,
each.
okay. It's you have to wait, but the gaps wouldn't there be wait? Oh yeah, you have like n seats, I guess we could say, and between them there's n minus one like gaps, and you pick where you want the consecutives, something like that. So you have like this is of size n.
So wait, not all the consecutives have to be the same number. Because you could have like, yeah, because you could have like 1, 1, 2, 2, and that'd be two consecutives.
And choose the seats. But then if we did it this way, then not all the seats are gonna be filled. What the fuck? N minus 1 to the power n minus 1 minus k. What's n minus 1 minus k? N is the length minus 1. And then minus k. K is the number of consecutives that we want. This because here I know there's an n minus 1 for this dp. Because I'm counting from 0. Length
What's the counting argument for this? I haven't
yeah.
done a counting argument forever.
Counting arguments usually use like some kind of like analogy with like seats or whatever.
Yeah. I guess it'd be like, okay, imagine you have like a bunch of chairs. And they have different colors. You have like you have M colored.
Yeah, M is the
You have a
number of
bunch of
different
chairs with
colors. Yeah.
M different colors. You need you need to line them up such that you have K of them. You have K situations where you have like two chairs of the same color in a row.
Yeah. N minus 1 choose K. You're choosing among N minus 1, K of them to be the consecutive targets. And then, because if this counts the number of consecutives that we're doing, well, let's say this sets like the positions of the consecutive. M is the number of ways, like the number of different colors that we can pick. But that's assuming all the consecutives are all of the same color, no?
Well, what if you think of them instead of thinking of them as like consecutives, think of it as like you need to place okay, you need to place pairs or something like within so like the pairs are like glued together. But then if you have more than two, then you can like I actually have no idea.
Me neither. uh,
Where's the proof for this?
Proof by God accepted.
If I answer correct.
Yeah. Mm. M minus 1. I mean, this M minus 1 has to do with like picking a different color.
Yeah, that makes sense to me.
Yeah.
Although I don't know how you deal with like the different
And
colors.
then N
Like you have like
minus 1 minus K. Okay, so N minus 1 has to do with like this thing. And then we're excluding the consecutive picks.
yeah.
Uh, Wait. But this N minus 1 comes back again. I'm not sure why it's N minus 1 instead of N.
Maybe
Mm.
there is no like nice counting way, and instead this just comes from like deriving some closed form from like some sum.
No, I'm sure it's a counting thing. This looks very much like a counting thing.
It looks so much like a counting thing, but I literally don't know what the argument is.
I think I think we're just too dumb to see it. I don't think it doesn't exist.
I know. It's probably like I always had trouble with this type of like when I did my discrete math exam in my first year. Um,
Yeah, counting
like
problems were
I
always a
finished the
struggle.
I literally spent the like we get 3 hours, right?
Hmm.
I spent I did the entire exam in 1 hour except for the counting question, and then I spent the rest of the 2 hours on the counting question and I couldn't figure it out.
Man, okay, yeah, counting is pretty cursed. Like, what made it easy for like my class is because the teacher would like, I think he went soft on us and he'd give us like variations in the exam of things that we've already seen.
Yeah. Like there's one like I couldn't figure out a nice argument. I just wrote some bullshit and I got like partial credit on it. So
So, how about we ignore the fact that it's n minus 1? So then,
even n choose k, like there's still like how does that count the
because if you pick like which like index gets, or maybe like n minus 1 has to do with, I don't know. No, it doesn't have to do with it. I don't fucking care. Like if you pick like index 0 to be the consecutive, you know that 0 and 1, index 0 and 1, it has to be the same value, right?
index 0 and 1? Yeah.
Yeah, if you pick like 7, then 7 and 8 have to be the same value.
Oh, you're right.
Yeah.
Okay, that no, that makes sense. That makes sense. That's why it's n minus one, because then you can't pick the last one.
Oh man, we. Now that makes sense. Now that makes sense. Okay, so n minus 1 has been cleared up.
Okay, we understand that part now. And
Okay,
then
and then times m. Why is it times m means the number? But wouldn't it be like, because you have all the different ways of picking, like which index gets consecutivized or whatever, right? Is there actually m ways? I would say that there's like this way, and then for each one is like every like permutation of colors, no?
every permutation of colors. Yeah, like well,
Oh, do they have to be exact same color? They don't have to be. If there's a gap
they don't
between
have
them,
to be.
yeah, if there's a gap, then they don't have to be.
Yeah, they don't have to be the same color.
It's just
Maybe
it's just like if you have the situation like x x x, right? This has like two sets of consecutive, right? Then this is forced
yeah,
to be
so
all the same.
in this case your choosing would be like 0, 1. Like here you like the choices from the n minus 1 choose k would be 0, 1, right?
Yeah, yeah, it'd be 0 and 1. Yeah. And in this case, they all have to be the same number. But if you have like x, x, and then you had like something in between an x, and well, it doesn't have to be x anymore. It could be like something else. It could be x, but it could be something else as well, right?
Yeah. I
If we
guess
just like if we just look at this one, it's
well that this is
yeah,
obvious. This is
yeah. This
obvious
is
what this
like
is.
everything in between the consecutives.
Yeah.
There's n factorial exponent n minus 1 minus k because it cannot be one of these ones. Wait, minus k. Oh, and the number of spots they are, right?
Yeah,
Yeah,
because you've already
n
filled
minus
k out.
1 is the number of options, and this is the number of spots.
Yeah, because
So this is permutations here.
if you selected k out of the n minus 1, you filled k, right? So there's n minus 1 minus k slots left.
Yeah, so this is
But
just
you've actually
per.
filled k plus 1 slots already because you have the extra one from the trailing.
Yeah, so
Um,
this is just the permutation of the rest, right?
yeah, it's actually more clear if you write n minus k plus 1.
Here.
Like
Oh, like
n
this.
minus bracket. Yeah.
Wait, like
Yeah,
you mean like this? Or
no. Like the way he had before.
like this?
Yeah, that's more clear, right?
1 plus why like this?
Because it like okay, so when you're choosing the consecutives, right? It's n minus one. So you pick one like n minus you pick k of those indices.
Mm-hmm.
Um, but the number of slots that actually occupies is k plus one.
Wait, it's only k plus 1 if they're all consecutive like this. What if it was
Oh
like,
wait, yeah, you're right. It's at least k plus one.
yeah. Wait, so that's where it kind of becomes cursed. Did it have to be? Wait. Uh, yeah, because k plus 1 makes sense if they're like all consecutive, like they're all next to each other, right? But if there's a gap, then it kind of like fucks it up. Because what if you had the example of like this one, right? So here you have 0, 1, 2, and 3 here, right? So out of 5, there's only one spot that needs to be filled with something else.
This is five. This is five, 3 2
This one?
or five m two, I guess.
What do you mean?
Like for the parameters that we're competing with, because there's five.
For this one?
N equals 5, k
Yeah,
equals
n equals
2,
5, k equals 2.
and then m is just whatever.
Yeah, m is whatever.
Uh, this is so cursed.
Yeah, it's pretty cursed.
Why is it so hard?
Oh no.
Like deriving the form, like proving the formula works is hell, but the solution is one line.
Yeah. I think we're just. I think like if we were just good at combinatorics, we would have just seen it right away.
Yo, this is a hard ass combinatorics problem, dude.
Yeah.
Like you have to somehow prove like the n minus one choose k and like the fucking like the m and the m minus one or whatever just like cancels out somehow and it perfectly balances out or something. Like
Wait, so this is the ways of choosing them. That's one way of choosing it, and then the other way would be like something in like this form, I guess, or 2 3 2, something like that. It's when they're all next to each other that it makes sense, but when there's a gap between them, that's when it becomes a bit cursed.
yeah.
Because m minus 1 is the number of options that are not to like break the consecutive streak, and then n minus k plus 1. That only makes sense if they're all consecutive, one after the other.
I haven't done combinatorics in so long.
Wait, let's try it on example 2 with the formula. Let's see what happens.
Okay.
So it's
What's the example?
uh, n equals 4, m equals 2,
Okay.
and k equals 2. So then
Okay.
that'd be
So
4.
n minus one, 3 choose
Oh,
2
whoops,
is
m is
3.
2. So it's 3, or yeah,
Choose
3
2.
choose
3
2.
choose 2 is 3 choose 2 is, oh no, it's 3.
That's
And then
1
n minus 1, it's just 1
to the power of
is
n. So
6.
4 minus 3, right? So that's 1.
Yeah, it's just 1. It's 6.
So 3 choose 2 is 3. Right? Okay, it's
Yeah.
equal to 3 choose. So 2 times 3 times 1. So we're saying this is permutation of the rest. So is there, I mean, permutation of the rest is like in the example of like, if you have like 1, 1, 1, 2, like once you set the 1 here, there's only one way of doing it here, right?
Yeah, and
But
there's two ways of placing those ones.
but what if you had the 1, 1, 2, 2 here? This example, how did it count this?
So I
So,
guess every time, okay, so like if you take the best case where like all of them are, let's think about like the best case where all of them are next to each other, like the consecutive ones.
so these are the three
So
cases
it
in the n minus 1 choose k, right?
yeah. Uh so if you take the best case, every time every time you pick a different number to have consecutive, it like splits off one, I think. Or every time you split, it adds every time you split the thing, it removes one from like the gaps. Like there's one less gap to fill
Huh?
because it gives you an excess number, I think.
I don't get it.
Because like here, there's three numbers, right? The consecutives, you've satisfied the consecutives, and you've used 3 slots to do it, or yeah, 3 slots to do it, right?
For the consecutive, well, there's this. These are the all the configurations, right?
Yeah, but like in the if you pick a different number for the consecutive,
For k,
in so like in your second example, 1 1 2 2,
yeah, 1, 1, 2, 2 could be 2,
then you've
2.
used an extra slot because like you have two numbers associated with the consecutives now. Or well, like you've you've broken it up, I guess.
Like you mean for this example, this way?
Yeah.
Like you broke it up, like you mean it's not like 3 in a row. It's like this and like that.
Yeah. Right.
Hmm. Hey, what if m was equals to 3?
Oh wait, I think I get it now.
Get it?
I think so. So like I think instead of writing it like this, I think you should write m. So like instead of putting the n minus one choose k in the middle, you should put it on the right. Or
So
put it on the left, like the leftmost. Yeah, move it to the left. So like first we think about that. So basically what that says is like how many ways are there to break it up like break up the array into k groups.
This thing.
Or, well, no.
This
What
is
is
the
it?
ways of picking the consecutive indices, right?
Oh yeah, what that does is it breaks the array up into n minus k plus 1 groups, right?
N minus 1 plus k groups.
Well, parentheses.
Okay, this. Because k plus 1
Because,
are the ones that aren't chosen.
yeah, because yeah, if you uh, hold on. Yeah, because if you look in the example, right, like here, so what you've done is you've broken it up into, actually no, it's n minus k. I lied. N minus k.
It's n minus k.
Yeah, it's n minus k. The groups of consecutive, like you break them up into blocks, right?
Mm-hmm.
Does that make sense?
N minus
Um,
k blocks of consecutives.
yeah.
Let's say you pick like 3 consecutives, and you had let's say
7.
7. Yeah, so you
Yeah.
have like, oh no,
Well,
like
if you just look at the simple example here, right? So
this one.
it doesn't matter because it's 4 and 2, so it's the same either way. But like, let's say you had 5.
5 n equals 5,
Yeah,
and k
and then k
equals,
was like 3 or something.
okay.
So we can just list out like the possibilities. So it's like x x
You
x
have
o
is
o
this
x x x x yeah x x x
one,
x
two,
o,
three, and then you can shift
and then
this is another way,
yeah, and
and
then
then
x x x o o, and then shift it, and then swap it. But you see what I mean, right? There's two groups, there's two blocks of consecutives here, right?
yeah, there's 2 blocks. Yeah, I see it.
Now just treat them as a unit.
Like these
So
as a
imagine,
unit.
yeah, now treat them as a unit, right? That
Okay,
can be
yeah,
any number.
yeah.
So
Okay, so
if
there's
you treat all of them as a unit, for the first number you have m choices,
so it blocks it
and then
breaks
for the
into
rest of them you
4.
have m minus 1 choices each. Then that's the proof.
Oh wait,
I figured it out.
wait. So it breaks them into groups. N minus k groups.
You
Wait,
have n minus k groups, right?
but why? So where does the n minus k come into this formula? Like here.
No, because yeah. So like this, because n minus 1 choose k is the same as,
You want to break it
yeah,
into
n
this
minus
formula?
1 choose k is the same as n minus 1 choose n minus 1 minus k, I think. Yes.
Choose. Wait, this is equals to n minus 1. Choose what? Oh, n minus 1 minus
Choose n
k.
minus 1 minus k, yeah.
Same as this.
But okay, the first thing I need to, do you agree that n minus 1 choose k like splits, it is like, it's the number of ways you can split it into groups, right? In consecutive blocks.
Uh, into consecutive blocks. Well, the way I would think of it is choosing like the indices that are forced to be consecutives. But is it the number of ways to
Yeah.
create blocks? Is it necessarily true? Because like let's say I can choose like these two to be consecutive, these two to be consecutive, and then these two, and then you have like A and B in between, right? Something like let's say you have a configuration like this. So this you have 1, 2, 3, 4, 5 blocks, right?
Oh wait, no, wait. Okay, hold on. I have a better way of thinking of this. Let me share my screen.
Yeah, go for it.
Okay. Um, Discord's being stupid right now. Why did it just die? Okay, there we go.
Wait, are you sharing?
No,
Okay.
why is it?
Damn, Photoshop. We're being fancy.
No, this isn't Photoshop. This is fucking Pinta.
This is what?
It's Pinta.
I don't
The
know.
Linux. It's a Linux thing. Can you see it
Okay.
though? Is it fine?
Yeah, I can see your screen.
You see me drawing?
No, I just see a blank canvas right now.
Hmm.
I see your
Uh,
pen moving, I think.
hold on. This is being stupid. Hold Let's try this again. It will load. Don't know why it takes so long. Okay. Are we good?
Oh, wait. Wait. The n minus k thing worked here again. Wait.
I can explain it. I see why it works now. So,
Wait. One, two,
so it
three,
was, yeah,
four,
n-1, choose
5.
k,
Wait, 1, 2, 3. Okay, it was
times
3, so we have 2, 3. And everything here has to be different. A, B, A, B, A.
So
Well, it doesn't have to be.
we need n consecutives, right?
Wait. 1, 2, 3, 4, 5, 6, 7, 8. I think that's a 1, 2, 3, 4. Okay, wait. So yeah, I see you're onto something. Go on.
I need to prove that n consecutive, like k consecutives is the same as partitioning into
Your stream is
n minus
loading.
k. I can see it. Do I need to stop and then start again?
I don't know if it's on my side or your side.
So weird sometimes.
Yeah.
Uh, it is a bit
2, 3,
finicky.
4, 5. 5 groups. N is the size. K is number of consecutives.
No?
Yeah, I can see now.
Okay. So like,
Oh, what the fuck? It turned green.
turn green, what?
Oh, now it's
Why?
black. Oh, oh. Now, I don't know. It looks fucking weird.
What happened? It looks fine on my side. Nice.
Wait, I'll take a. Wait, draw something and then I'll show you what I see. Yeah, it's pretty cursed. I sent you a screenshot.
What the fuck? Why is it like that?
Oh, wait, I don't
Hold
know.
on,
Wait, let me stop
what if I
streaming.
screenshot a different display? What if I just screen share this display? Is it okay now?
Yeah, now I can see. Yeah, no, I think it's fine now.
Okay, I think it's just because that was my other monitor, just being weird. Um,
Oh, what the fuck? It turned green again.
what? Bro, why?
Now it's back to being cursed.
What happened?
Oh wait, now I can see. I can see. I can see.
Okay.
I don't know how long you'll last though. Okay.
Um, okay. The K consecutives. So we have A. Why are there all these fucking squares? Why does it have this many squares, dude?
I
Squares are
don't know.
fucking ass.
Can you pretend like they're not there or they're just that annoying?
It's fine. Yeah, it's whatever. Um, so what we want to prove is that like K consecutives equals like n minus K um
Groupings?
blocks, right?
Yeah.
Yeah, groupings. How can I prove this? Because if you can get this, then this falls into place.
Okay, let's assume it's true then. N minus
Okay.
k.
Well,
There's n minus k groupings.
if you assume this is true, like then the rest of this formula becomes very obvious because basically you can treat each grouping as a
Like
single number.
yeah, but they can't be the same. Consecutive groupings can't be the same, right?
Yeah, so like but if you treat them as like single entities, right? That
Mm-hmm.
can be like because they all have to be the same number, right? Then for the first grouping you have m choices.
Yeah. Oh, and then
And
the
then
rest.
you have n minus k
Oh, and then
minus
minus one
1
because of that first grouping.
minus you have minus 1 choices left and these all can all be n minus 1, right?
Oh, and n minus one choose k is the number of ways to create groupings.
Yeah.
Oh, okay. N minus one choose k is the number of ways to create groupings. Yeah, yeah, I could see that.
That's the part I don't know how to prove right now.
What?
But
Oh, the that there's n minus k groupings.
yeah.
Okay, let me think of
But if you
that.
assume it's true,
Then it
then
falls into
this
place.
yeah, right? Because you can treat all of them
Yeah,
individually
because
and then
n
this
minus one choose k is the number of ways to create groupings, right?
yeah.
Yeah.
And then
And
for each group, for the first one, you have m choices, and then for all the other
oh
ones, you have
yeah,
m minus 1 choices.
yeah, because they just have to be different from the previous one. Oh yeah, that's big brain, Jeff.
Okay, but how do I
Yeah,
prove this?
there's
I'm gonna
n.
give this like another 5 minutes, and then I'm going to bed because I'm tired.
uh, so there's n minus k groupings. That's what we're trying to prove. K is the number of consecutives. N is the number of elements. So let's take. Can we prove it by induction? Let's say that k is
Assume that
0.
is true.
No, by
Assume that
induct
is true.
by induction. So we start with k equals 0. So there's
K
n
equals
groups.
0, then
There's n groups because they all have to be different, right? That's a base case.
uh, K equals 0. Yeah, there's n groups.
And then k equals 1. So you have to take out one element, right? Because there's two consecutives. They have to be the same, and then the other ones have to be distinct, right? And then now
Yeah.
Now k equals 2. So now that second element either is like adjacent to them or like somewhere else, right?
Mm,
Does that make sense? So you have
you
like,
either add one on or you merge something else.
yeah, so it's either like it goes like next to them, so like either like it goes like here. So in that case, you take out one more element so that n minus 2 works, or you shove it somewhere else. And if you shove it somewhere else, you'd have like an XX, or like not an XX, but let's say like a YY somewhere else, right?
Yeah, I'm trying to think if I think of it like
But
this.
but that first Y was already free, right? It's the second one that became fixed, right?
Mm,
So only
wait,
one
wait.
of them became fixed. Does that make sense? Because you have two cases. Either you pick like adjacent to the two that you already fixed, so one of them becomes not one is no longer free. If you picked it somewhere else, one of them was already free, and just the one that was adjacent is not free anymore. And then the same logic applies for all the others.
One of them that was free is not free anymore.
Yeah. So
And then
let's just like so I'll just draw like circles as slots, right? So like let's say these are the n
are you,
elements, right?
are you
Right
sharing?
now, oh right, I'm not sharing. I'm talking to myself.
Yeah.
Yeah, I think the proof by induction kind of works. Let
I'm
me know
thinking
if
about it like, what if you just put
can you see my
separators in
screen?
between the slots? Yeah, I can see it.
So here you have n elements, and if k equals 0, they're all distinct, right? So there's
Yeah,
n groupings, right? If k is equals to 1, then we pick any one of them, and now these two are forced to be the same, right?
yeah,
So now there's n minus 1 grouping, right? Because now these two are linked together as a group.
yeah.
Now and then now k equals 2, you have two ways of doing it. Either you go grab these ones, right? Or you grab it somewhere else, right? If you grab it next to this one, then now this one becomes fixed to whatever it was here, right?
And there's still
So
there's still four groups.
yeah, so now you're doing minus 1 because you increase k by plus 1, right? So that
Yeah,
proves for k minus k plus 2 for this case. Or you could also pick it here, right? Let's say that here was fixed to like 3, right? But or I mean this could be anything. So this is like I don't know, let's call it like alpha, right? This before could have been anything, but because we selected this one, now this is fixed to alpha. So this one was free, right? So this one still had like m ways, right? Or yeah, m minus 1 ways, whatever. This one used to have m ways, but now it became one way, right?
yeah. And then
So in
for
both
any
cases,
k,
by increasing
it
k,
adds one group. Well,
yeah,
it
no, it's
removes one
yeah,
group.
exactly. By increasing k by 1, in both cases, either you pick it next to a current existing consecutives or somewhere that doesn't exist, then it just removes one. And then the same logic applies to any number of k's, right?
Yeah.
Does that convince
Uh,
you?
like yeah, this works, but I feel like there's a simpler explanation rather than just relying on
Yeah,
induction.
yeah. But it works. It works. mm,
Okay, wait. So if you're picking k, that means you're picking k indices, right? So let's say k equals 2.
yeah, k equals 2, so you're picking, let's say, like this one and this one at random, right?
Yeah. So then that means that means that
These ones become fixed, and
if
then this one becomes fixed. Yeah, so I think for like K, every
That means
time
yeah, that means that this. Hmm?
like K's, they just like like one variable that used to be free becomes now fixed, right? For every K.
Yes. If you look at my screen, so like let's say you pick this. Let's say you pick this configuration
Wait, your screen is loading. Wait, I'll stop
again.
streaming and then watch
Yeah, you
streaming.
stop streaming, and
Oh
that's
yeah, I'll stop streaming. I don't know if it's because we're both streaming. Wait,
you see now.
it's still loading.
So annoying.
I know.
But like my idea is that every empty slot becomes associated with a group.
Yeah, exactly. That's what I was thinking. Before and like groups of one count, right?
Yeah. So
Yeah.
like here,
Before like every
uh,
group, like for k equals 0, like every group is independent, and then for every k, it makes like one of the ends join a group of k's, right?
can you see it now?
Yeah, I can
I'm
see
just
now.
sharing Discord right now. Okay, yeah. Okay, yeah. So like let's say you pick this configuration,
Oh, you can think of it as
then
associated to the ones before
yeah, well you can I think of it as like
or after
any
the.
empty slot becomes associated with a group, right? Because this is its own element.
Wait, no, now I can't see anything. It turned dark.
What?
Okay. Oh, wait, now I
What?
can see. Yeah,
That's so interesting. You good now?
yeah, it's good now.
Okay. So like let's say you pick these two indices
Mm-hmm.
or like the consecutives, right?
Yeah.
Right?
Mm-hmm.
So then every empty index becomes associated with a group. This is its own element right here.
Mm-hmm.
These two, no, this is its own element right here.
Mm-hmm.
This empty slot right here is associated to this pair,
Yeah.
and this is associated to this pair.
Yeah.
But if you picked adjacent elements, then this is still its own, like, this is still, this is now tied to all of these, right?
Yeah.
And now this is this, and this is zone, right? So like every empty slot is associated to a group because it's either the last, like every empty slot is the last empty slot after an arrow or
Mm-hmm.
after a chosen index, right?
Mm-hmm.
After, because like this run of indices ends in this empty slot. So this empty slot becomes the representative for this group,
Yeah.
right? And then this empty slot has no arrows before it, so it's its own group.
Mm-hmm.
And this empty slot has no arrows before it, so it's its own group. And then, yeah. So
Wait, so,
thus,
and that's to prove number of groups equals n minus k.
is equal to n minus 1 choose k.
Wait, that no n minus one choose k is the number of different ways of grouping them. Like number of ways to place the arrows, right?
Yeah, but it's also equal to the number of yeah, it's the number of ways to partition it into n minus k groups.
Yeah, but wait, but how does it prove? How does this explanation prove that there's n minus k groups?
Because so if you wait. Oh yeah, because if you pick because in the wait, because no, because if you pick like k indices
Mm-hmm.
out of the n minus 1,
Yeah.
then like because you have n minus 1 choices, but the whole array is n, right?
Mm-hmm.
So if you pick if you pick k indices, then you're left with n minus k groups
N minus k
always.
groups. Yeah, but why?
Because you can't, okay, because like each group has to end with an empty space,
Yeah.
right? But you can't pick these two. So like you won't ever you can't it's impossible to pick it's impossible to have a grouping that doesn't end with like an empty space. Because you can only pick out of these five. You can't pick here. Because like picking an index means that the next element has to be the same, right?
Yeah.
So no matter how you pick here, there's always going to be n minus k empty spaces, right?
Oh, I think I get it. Like for every arrow that you place, that value is fixed to the rightmost value that's not an arrow.
Yes, exactly.
Okay, yeah, I see. So then the question is how many. Okay, so then that's just how many. Yeah, so that just reduces to how many empty spots are left, right?
Yeah, exactly.
Okay,
And
yeah, yeah,
then now you've proven that's how many groups there are,
yeah.
or that's how
Like
many ways there are to pick
all
this
the
many
arrows
groups,
are
and then you just
forced to have the value of the rightmost spot, and so they're part of the
yeah,
same group.
exactly.
So how many ways can you like, or yeah, how many groupings are there? It's the number of empty spots.
Yes.
Because
And then once
every
you
empty
have
spot's just like takes every arrow on its left, right? As the group.
exactly,
Okay,
yes.
yeah. That makes a lot of sense.
And then the rest of the formula is obvious
Yeah,
once you have that.
the first one is m, and then everything after is m-1. Oh my
Yeah,
god.
exactly.
There's no fucking way I could have come. Like, I don't think either of us could ever come up with this shit.
At least we
Yeah.
figured out the explanation on our own.
Yeah.
Once we saw the formula, we didn't have to have someone else explain it to us.
We had to work so fucking hard to get it. Oh, but now it makes a lot of
Combinatorics is
sense.
so hard.
Yo,
Combinatorics is so hard.
yeah, this shit is fucking hard. Yo, when I took the class, it was so AIDS. The only thing that made it easy, I don't think people, like some people don't realize it, is just because the teacher's making variations. But if you took like a new question that you didn't see, bro, it's the hardest shit in the world.
Yeah. Like I still have to take more discrete math. Like I have to take like discrete math 2, which is apparently it's all just combinatorics and graph theory.
Oh
That's like
shit.
what the prof teaches. He doesn't teach anything else.
No, but it's really fun though. Well, it's fun when you get it. Yeah.
Yeah.
Hard things
It's
are
the type of
fun
thing
when you figure it out.
it's the type of questions that it's like when someone explains to you that like explains it to you, it's like so obvious. But then it'll take you like 3 hours to come up with it yourself. Or you won't ever come up with it.
Yeah. Like when it clicks, it really clicks, but before that it's
Yeah,
just like a bunch of mumbo jumbo.
exactly.
Oh man. Yeah. Yeah. All right. Let's go.
Alright.
That's it for today.
Yeah, that's it. I'm so done, dude.
Same.
I'm out.
All right. Good night, Jeff.
See ya.
Bye. Bye bye.